Welcome to today's Explainer. Take a quick second to think about your everyday experience of reality. You know, the way you feel time ticking away, the way light bounces around the room you're in, the sheer physical space you occupy. It all feels so incredibly reliable, right? So absolute. But out there in the depths of the cosmos, there are these enigmatic, absolutely awe-inspiring locations where every single rule you intuitively understand about reality just shatters. Imagine a place where gravity is so overwhelmingly powerful that it actually warps the flow of time, and where not even a single photon of light can escape its grasp. These cosmic monsters are what we call black holes.
But right off the bat, that brings up a pretty massive paradox. I mean, if light can't return to our telescopes, how do we even know they're out there? How do you see the invisible? Well, today, we're going on a fascinating journey through our source material to answer exactly that. We're going to travel from the spectacular violent death of a massive star straight to the most dangerous, time-bending edge in the cosmos.
Okay, let's dive into this. What actually is a black hole? It's a term we hear all the time, right? Sci-fi movies, pop culture, it's everywhere. But when you strip away the Hollywood myths and get down to the actual astrophysics, the reality of what these things are is way stranger and honestly way more terrifying than anything you'll see in the movies.
To really understand it, we need to clear up a super common misconception. A black hole is not just some empty void or a giant cosmic vacuum cleaner roaming around space. Actually, scratch that, it's not a hole at all. It's a gravitational object formed from an insanely concentrated state of matter. We're talking about an enormous amount of mass packed into an unimaginably tiny, microscopic region. And because of that extreme density, it heavily, violently distorts the fabric of space around it. And since space and time are permanently linked together, it fundamentally distorts space-time itself. That intense warping creates an inescapable trap. But to really grasp how something so extreme even gets made, we kind of have to go back to the beginning.
We need to rewind the clock and look at the origin story of this phenomenon. It all starts with a massive star. A star that has been shining and burning incredibly bright for millions, maybe even billions of years. And you know, stars aren't just sitting there peacefully in the dark. They are engines of intense, unimaginable power, and they are constantly fighting a literally explosive battle for their own survival.
And this brilliantly illustrates the delicate cosmic balance happening deep inside every star. It's basically a billion-year tug of war. On one side, you have nuclear fusion constantly firing off in the core, generating massive amounts of energy that pushes outward. On the other side, you have the immense inward pull of gravity, just constantly trying to crush the star under its own astronomical weight. For millions of years, these two forces are locked in a perfect stalemate. The outward pressure flawlessly balances that inward pull.
But here's the catch. Stars don't have an infinite supply of fuel. Suddenly, eventually, the core fuel runs out.